Welcome to 2021's memo. So this is part one. So let's get right into it. So we're gonna start with question one as always, and then we'll work our way from there. So let me open Dia. Okay, there we go. There's Dia. So yeah, I'm gonna keep going back to the question. Okay, the UML, use the UML to model the following scenario. A weather predictor has a real valued computer time, budget, and a value, and a volume, and a volume made up of three integers, which are set when a predictor is created. Okay, so we're gonna have a weather predictor. So remember when you name classes, right? There are no spaces between the words, and you have to write them in uppercase. Each the first letter of each word has to be in uppercase. So yeah, just keep that in mind. So let's drag and drop our class, then double click. I don't know why it was doing that. So there we go. We have weather predictor, no spaces in between. Because if you put the spaces, it's going to treat them as two different words. Like remember, the computer is very literal. So if you put that space, it's going to think weather is its own class, predictor is its own class. Then it is attributes, right? It is variables, it is data. So what is the data? What are the attributes? So the attributes, they said it has a time budget, right? A computer time budget. So I'm just going to call it time underscore budget. You can use camel case where the first letter, the word of the letter of the first word is a lowercase, and each subsequent word starts with an uppercase. So time is going to have a lowercase, and then the next word after time, budget, is going to have an uppercase letter, and then yeah, and so on. So I'm just going to use the underscores to separate each word, keep it simple. And they said it's a real value, right? Real value meaning that it's an integer. So int and then private. There we go. It's private, right? And then we're going to have another variable called volume, which is a volume, right? So it's going to be, basically it's going to be a record structure, right? Because they said it's made up of three integers. So it's going to be a record structure. But they're just going to assume it's a record structure. You don't have to worry about it. So it's going to be volume. And then I'm going to call it volume, right? So they just going to assume that it's a record structure. And then it's going to be private, right? You don't have to worry about being explicit and showing, okay, this is a record structure. It doesn't really matter because it's just simple UML. And then we are done with our variables. Okay. We're not necessarily done, but let's just answer the question up until here. You see, up until this full stop. So we have made the time budget or the computer time budget and a volume, which is just three integers. And then they said which are set when the predictor is created. Basically, remember the builders, the constructors, the builders. That's what they mean. So you set them when you are when you're creating the object. So I'm going to create a constructor, parameterless one. That's going to be the first one. Then the second one is going to be parameterized. And then I pass in the parameters. So I just go under here where it says parameters and then I say new to add a new parameter. So what is the parameter going to be called? It's going to be called, I'm just going to call it time budget like this. Then it's going to be of type int. And then it's also going to take in a volume. That's the name. And then the data type is going to be of type volume, like that. So I'm going to rename my volume to put so that it has an underscore in the front. And then even the time budget, you could just say underscore and then something like this. Yeah, let's just use camel case so that I can put that underscore there. And then, yeah, now it knows the difference between the parameter and the class instance. And then let's see, we should also have a, you don't necessarily have to put it, but you should also have a copy constructor. Yeah, I think it's always good to just always put the copy constructor there. And you specify the parameter, what parameters it's going to take. It's going to take obj predictor. I'm just going to call it obj predictor. That's the name. The type it's going to take in. It's going to be a const weather predictor by reference, by address. And then I click apply. So there we go. I have my constructors, right? The different types of builders. I've added the builders that are going to build the object. Now we need to continue and add what we are supposed to add. You see, they said in addition. So on top of what you already created, it has three-dimensional collection of air cells. So three-dimensional collection, right? Of which whose life cycle it what manages. So three-dimensional, it means that you're gonna have 3 pointers because it manages its life cycle. That means it does allocate. So it means it's gonna be dynamic. Since they didn't say what size it's going to be, so it's going to be dynamic. Just assume it's going to be dynamic. And remember, pointers help us to create dynamic memory management. So we're allocating memory ourselves and then we deallocate memory ourselves. That's where they come in place. So I'm going to call it underscore air. Then what's the next word after air? It's cell. So I'm going to put it in uppercase on it, air cell. And then it's going to be of type air cell. And then there's going to be three-dimensional, 3 pointers. Remember what he said. Each pointer, we can use it to represent each dimension. And then it's going to be private. And then I click apply so that it applies the changes. And it hasn't talked about, remember that the part about which are set when the predictor is created, it hasn't talked about it. It didn't say we should get a value from the constructor and initialize the SLs that we're managing. No, it didn't talk about any of that. So you don't have to pass it via the constructor, and you also don't have to make an accessor and mutator. They haven't talked about any of those things so far because we've read up until here. That's the only information we have so far. Then now they're talking about each air cell contains a set of, you see, now the okay, three-dimensional collection of air cells. Yeah, three-dimensional collection. That's fine. Three pointers. And then each air cell contains, you see, each air cell. So basically what this means is that you're done creating the weather predictor. You must move on to the next class called air cell. Yeah, okay, for now, like what I like to do, right, is that I write everything as I'm reading it. There might be more information that I need to add in the weather predictor, but I'll add it after. Because right now they're talking about air cell. I must create an air cell class. So I'm gonna click OK, and then put this diagram, this UML diagram on the side. And then now we get to the air cell. So remember, it's going to be air cell, right? And then it's going to have a set of integers, x, z, and x, y, z. So it's going to have 3 integers. So it's going to have x of type int. Remember, all the data is going to be private. Y. Okay, let me just say underscore. Okay, I didn't provide the type for y. It's going to be of type int. And here it's going to be underscore z. And the type is going to be int. And I must change the visibility to private. Remember that everything should be private by default. Then the things that that should be visible, we use accessors so that the user can have access to it. And then each SL contains a set of integers values which indicate its position, right? Within a 3-dimensional space as real values indicating. Oh, okay. We are done with that 3-dimensional, as well as real values indicating the temperature. I don't know, for some weird reason, in some tutorials, real values an integer. Is it? Let me just confirm because I'm pretty sure a real value is an integer. Is a real value. Something tells me it's also a double. I'm not sure. Okay, not this. Okay, let's just ask ChatGPT. What is a real value in programming? Basically, what is the actual data type of it? It should be okay. Yeah, I was, I was insinuating that this could be a double or something, but I don't know, for some weird reason. I think in some memorandums or whatever, I think I saw it as an integer. So that confused me from that moment. So yeah, to be a real value is actually a thing, a double. So just keep that in mind. Yeah, English can be confusing at times. So let's just fix the time budget to be a double. Because I said the time budget is a real value. And then now we need to have, because I saw that this is a temperature, it has to be a double. Real valued computer time. These people, I don't know, I feel like maybe in some memorandums they make mistakes, but yeah, I've definitely seen it somewhere where there was a real value and they chose an integer. I think it was in the practicals. They said real value, and then when you see the example, it's an integer. It's confusing. They must choose one thing. The real value should be an integer, a thing, a double, and then a whole number should be an integer. That's how we should be distinguishing these two things. So indicating the temperature, pressure, and humidity. So it's doubles, right? Pressure, the temperature, pressure, humidity. So I'm gonna have underscore temperature, which is a real value, and the real value is a double. And then underscore pressure, double. Then apply, and then we're gonna have humidity, double. Apply. Okay, so we have our real values, our doubles, temperature, pressure, and humidity. So these values need to be accessible and modifiable. So that means it's going to be a lot. So that means every value that you have inside inside the SL, it should be modifiable and accessible. So you must create accessors and getters for all of them. X, Y, Z. Yeah, it's going to be a lot. So let me see both. Okay, so they need to be accessible and modifiable. So they didn't talk about you setting them when the predictor on the what is created. So there's no need for me to put constructors here. All I have to do is create accessors and mutators. So what's the name that I'm going to call it? Get X to get the X value. Type is going to be int because that value is of type int. And then get Y going to be of type int. Then get Z, get the Z value, it's going to be of type int. Now we create the, okay, let's also create accessors for the pressure, for the temperature, pressure, and humidity. So I'm gonna say get temperature, because if I say get temp means temporary too. It's an abbreviation for temporary. There's a lot of words you can use there. So I'm just gonna write it in full and call it get temperature. And then remember, those values are real values or doubles. And then get pressure is a double. And then get humidity is a double. And then now we create setters. So I'm going to set X first. The return type is going to be void because it's just setting X. So the name of the variable that it's going to be taking in is just X, because remember my attributes, I created them with underscores. So I can use the same name for the parameters as long as I don't put the underscores in the parameters. You will know the difference. It's going to be of type int, then set Y, void takes in variable named Y of type int, then set Z, void was just setting, and then Z, then int. And then now we get to the temperature and pressure and humidity. So set temperature, I'm gonna write it in full. Then void the new, I'm gonna take in a temperature, type double. Then I'm gonna have set pressure. Then it's gonna be of type void, return, it's gonna return nothing. And then I'm gonna take in pressure. And then it's gonna be of type double. Then the last one, set humidity, gonna be of type void, takes in a humidity, type double. And then there we go. We have all our accessors and setters and mutators, getters and setters. So now what they're saying is that both the weather predictor and S cells have a simulate behavior. So basically, it's remember we have data and behavior in a class. Data meaning variables, and behavior meaning functions. You can call it behavior. You can call it operation. You can call it yeah, behavior, operation. That's basically functions. And then data, that's variables. So it's a simulate behavior. So you must, it's supposed to simulate, right? So I'm gonna call it simulate so that it makes things easier to understand. So the predictor, right, it delegates this to its cells, right? So it delegates it to the air cells, and then the air cells does the management, the life cycle management. So what's going to happen here, right, is this. I'm going to go inside air cell. Remember air cell, remember when you're doing delegation, you have the simulate function, right? But then within that class, um, let me see. Name the function that override simulate behavior. So the simulate behavior delegates this to itself. Okay, let's do that part, delegating, right? So obviously I must take in a weather. I'm gonna call it a predictor. It's going to take in a weather predictor by reference. The question is if it's by reference, have a simulate behavior. The predictor delegates this to its cells. So since it delegates to the cells, I'm assuming that it's going to change or modify the weather predictor. So therefore, I'm going to pass it by address, by address, and I won't put the prefix const. I won't pass it by const reference. I'll just pass it by reference, so that this ASL can modify or perform the simulate behavior. And then inside my weather predictor, remember we also need to have it here, the simulate. And then here it won't pass in anything because we're going to use the dereference operator, dereference this, and then if you remember delegation, then we are done with these classes, right? Now I need to create the two kinds of predictors. There's the long term and short term, which override the simulate behavior. So basically they override the simulate behavior. So basically it's going to be a virtual function. It's going to be a virtual function that since they have to override it, it's going to be a virtual function. I could come here and change its inheritance type to polymorphic or virtual. It should make it a bit sort of like Kaylee. Yeah, it's Kaylee, you see. It's no, it's not Kaylee, it's italic. I mean, you see, it becomes italic, then you'll know, oh, okay, this function must be overridden. So you can do that, but it's I'm only doing this. It's only possible for me to do this because of this app that I'm using. Since you'll be writing it on a piece of paper, it's fine. You can just write it here. When you redefine it inside the child classes, they know, oh, this is a function that the child classes override. You don't have to write a lot of things there. You just write it the way you long term, then it has a simulate behavior. Simulate void. Try, there we go. And then short term, short term, then I'm going to have the simulate function void, then apply. Okay, so our child classes are very small. So it's going to be like this. Then now we do the inheritance. So I'm going to be like this. And then also like this. Then now it knows, okay, there's two classes inherit from this. And then remember that this is composition. Look at the type ASL. This is within, it's inside of this. So the arrow must go from there to this side. But then remember it's that diamond must point to this side. Like this. And then remember now it's managing its life cycle. There's life cycle management. So this class cannot exist without that other class. Because if that other class doesn't exist, it won't be able to exist. You can't instantiate, you can't create the object. So it's going to be composition. If there was no life cycle dependency, then we would have to make it leave it unshaded, not shaded in, like just leave it white, because that would be aggregation. There's no life cycle dependency. Then I'm going to export this. Okay, export as SVG, scalable vector graphics. And then I'm gonna call it UML 2021, right? And then I'm gonna save it under documents. And save it under documents. There we go. And then let's check on documents if it's saved. There's the SVG. So what I would do is I'll create a new folder, right, and call it computer science 2021 1B 2021 demo. There we go. So I'm gonna save everything inside this folder so that I won't forget to send some things when I have to send. So there we go. We have done the question as we were asked to do. We have all the getters and setters, and then we have the weather predictor, the inheritance, virtual function, all of that. We have everything. So we are done with question 1. So since we're done with question 1, now we can move on to the next question. So the next question is 1.2. So let me do this. Okay, let me just save it inside main.cpp file. So let's create a new file and call it semester no exam 2021 memo.cpp. Then I'm gonna save it under documents inside that folder that we created. And then I'm gonna say hash include IO stream int main and then return 0 for success. Yeah, I'm just gonna write it like this. Let's have one file that is everything. For the questions that you have to answer, I'm just gonna make it a comment and then write the answer. Because this thing of having to share different documents, it's like a bit confusing. So 1.2. A class often has multiple constructors, right? Yeah, it can have different types of builders. Some builders, they don't need any information. That's a default constructor. Some builders need more information, like how big the object is going to be, what is the default value for the object. That's a different type of builder. Then we have the copy constructor, that builder that copies from what other builders have built. So that's true. We're gonna have a lot. We usually have a lot of constructors, which differ in terms of their parameter lists. Exactly, just like I just said right now. What is this example of? So what is the example of having a lot of things that have the same name? Yeah, that have the same name but different parameters. We call that overloading. That's called overloading. So there's constructor overloading when you have constructors that have the same name, but then the parameters are different. The data type or the order or the number, but then they have the same name. The important thing is that they have the same name. That's overloading. It could be functions, it could be constructors, it's still the same thing. So the answer is going to be D. In more straightforward terms, or to explain it a bit better, it's actually called constructor overloading because you're overloading constructors. And then assume that A has a B, right? So basically this class has a instance or an object of this class. So we have composition there. It's either composition or what is this? Not delegation, what am I saying? It's either composition or aggregation. So whenever A is instantiated, so too is B. You see, We have a cycle. We have a we have a we have a cycle dependence here. So there's a dependence. Whenever A is created, B is destroyed, B is also destroyed. So you see, they that object B, it depends on the existence of A in order for it to exist, because A is the one that's managing its existence. So since there's that dependency there, it's going to be composition. They depend on each other. It's like, for example, I'll just give you a simple example. It's like, in order for you to exist, you as an individual, in order for you to exist, you depend on your parents' existence. If your parents didn't exist, you wouldn't exist. That's composition. You can say, oh well, now I'm old, I don't need them to manage me, to do this and that. But well, in order for you to exist, they had to manage you. They allocated memory for you, and then you came into existence. When your mother was eating, you were also eating. So there's that circle dependence. You're dependent on your parents' existence in order for you to exist. Even when you were born, in order for you to exist, you had to do whatever your parents did. If they ate, you also had to eat. If they if they um if they go out, whatever they're doing, you're sort of like part of that. You're also involved. So it's like you're sort of like a copycat. Whatever your parents did, you also did. So that's definitely composition. You cannot exist without the existence of that class that you are in. So for example, you are in your mother's womb, right? So you cannot exist without the existence of your own mother. If your mother didn't exist, you wouldn't exist. So that's composition. But if you are made, for example, in a lab, you didn't need anyone in order for you to exist. So that would be aggregation. So yeah, for example, if you were some clone or whatever, but okay, I would say with clones, you'd have that person need to exist, yeah, but not necessarily clones. Let's just say you were made in the lab from scratch. Because there's if you read the news or whatever, there's been rumors that they can now make artificial wombs and whatnot. So you see, they don't need the human being to exist in order to make a life. So that would be aggregation. But then if you're born the natural way, if your parents didn't exist, you also wouldn't exist. So you depend on their existence because they are the ones who are going to manage your life. When you need to go to school and fees have to be paid, who pays them? Your parents. When you want something to eat, who are you going to look at? Your parents. So your parents are managing your existence. They're always there, here and there, helping out. If you are hungry, you eat. If you are sick, they take you to the doctor. They are managing your existence, your life cycle. So that definitely would be composition. So there's going to be a composition. Then 1.4. 1.4, assume that class A is an abstract base class, and that, okay, it's an abstract base class. Remember, an abstract base class, in order for a class to be abstract, it must have an abstract function, or basically it must have, yeah, in simple terms, that's what it means. And by abstract function, we mean the virtual keyword. The virtual keyword makes the function abstract. Abstract meaning that it's not going to have implementation, and you have to make sure it's pure virtual so that you don't actually provide the implementation. It has no implementation at all. So therefore, now we know for sure that class is abstract. That means it's definitely an abstract function, or an incomplete function, or a function without code. That's an abstract. That's why a base class would become abstract. And B is derived from A. So basically B inherits from A. Is B also an abstract base class given the fact that the following code compiles correctly? Oh, so if this code compiles correctly, yeah, it makes sense. But you have to understand what's going on here. What they're asking you is that, does this mean that the child class B, is it also a the child class B, is it also an abstract class or not? True or false? If you're saying it's also an abstract class, then you say true. If you're saying it's not an abstract class, then you'd say false. You need to understand the question here. Is B also an abstract class? If you're saying yes, you're saying yes, it is. If you say true, it means you're saying yes, it is also an abstract class. But then if you say false, you mean you're saying no, it is not an abstract class. Remember, an abstract class, you can't instantiate an abstract class. What does it mean to instantiate? You can't create a variable of which the data type is the name of that class if the class itself is an incomplete function or has an abstract function. Let me show you. Let's create a shape, right? Let's say we have a shape class. Here's a shape class. And then it's going to have just one function. It's going to be a draw function, right? Why is it taking so much time? And then we're going to make it a virtual function. By make it virtual, this means that this function is abstract. Some languages, they make it simple. They actually use the word abstract so that you don't get confused. So instead of here, they'll just say abstract like this. But then in C++, they chose the keyword virtual. So abstract meaning that it's incomplete. So you see, there's a virtual function, right? Let's try to create an instance or to create a variable of type shape. Let's see if it's possible. It shouldn't be possible because this is an incomplete type. It's like, for example, you're trying to say, you see, object of abstract class type shape is not allowed. You can't do this. You can create. Let's try to even instantiate it now. New shape, right? You can't do that. You can't instantiate. You see, it is a pure virtual function. That's what I like about what is this VS Code? It gives you all the information that you need. Even though it's not like it doesn't have all the tools you need for C++, but it gives you exactly the error that's causing this thing. What is going on? There's a pure virtual function. Basically, what it's telling you is that there's an abstract function. You cannot create an instance or just create an instance of this class as long as it's incomplete. This class is incomplete. There's missing code. You see, when you write it like this, what you're saying is that I'm going to create a building, right? And that building, I won't put windows in any of the floors. But then I expect people to move in and stay. That's not how we do that. That's not how it works. You'd get sued because of that, and they don't even allow you to even take in any tenants in. You are not even allowed to do that. The object has to be complete before you can use it. For example, the building, what if it starts raining now? There's no windows, it's incomplete. People become wet. And when that rain goes in, there's electrical appliances there. Rain and electricity, when they combine, what's going to happen? People are going to explode. It's going to burn people. The building is going to explode. You see, all of these things end up creating more problems. So that's why, remember what I said, the computer copies what we have in this real world. That's why I'm making a real world example. So this is why it's complaining, which is very good because I cannot create an instance or I cannot build the object if it's incomplete. I can't say expect people to move in a building that's incomplete. There's no windows. To make it matters worse, they say there's no windows and there's no doors. There's no doors anywhere. In the toilet, in the shower, in the front door, the main door, there's no door anywhere. So that means if I'm cooking or I am taking a shower, anyone can just come in and 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 just see what I'm doing. right? Which is a problem. Now it raises issues of privacy, all of those things. So that's why when you get into a new apartment or a building or a residence or whatever that place is, it has everything. There's a door, there's windows, and even the toilet is a door. There's everything. It's a complete structure. It's a complete object. So the same applies in programming. You have to make sure it's complete before you can instantiate it. So now let's just say this is A, right? Based on that example, that's class A. And then class B is class B, right? It inherits from class A. So class A, like this. So since it inherits, it's going to also have that virtual function. I don't need to write the virtual, it's just for me to make sure that it's just for me to remember that, okay, this was the function that was abstract. So now I'm overriding that function. It just helps me to remember. So new shape, right? So now there's no class called shape. I'm gonna call it A. And then if you check, you see, I cannot create that object. It's impossible. The class is incomplete. You see, object of abstract class type A is not allowed. You can't create an object for an abstract class. So what I can do is I can create though an object of class B, right? Just gonna call it A. I don't know why it's doing this, but it should allow you, but okay. Yeah, but now I see why they said it like this. So let's see. Is B also an abstract base class given the fact that this code compiles correctly? So if this code runs correctly, assume that it runs correctly, because they knew that, yeah, you're gonna face this issue, it won't run. They're just saying assume that it runs correctly. It should, if it runs correctly, right? Remember what's happening in this one line of code. I can use the name of my base class to instantiate a child class. It's allowed. As long as the thing that I'm instantiating on the right hand side is a child of this base class. It's allowed. So it should work. So you may assume that this line of code works, right? If it works, that means I'm instantiating this class, an instance of class B. And I can create class B. Why? Because it doesn't have a pure virtual function. It doesn't have an abstract function. I think it's doing this because I don't have it like this. Let me see. Okay, it's still complaining. It's fine. But yeah, you can implement that function like this. But let's see. Let's try to create the class B, and you see that it's going to be fine. It's going to work. You see, there we go. I can create an instance of B. Why am I able to create? This is just a virtual function. Basically, it means that it might, the virtual keyword in this instance, it's just basically making it an overrideable function. Overrideable meaning that you can override this function. But then when you override it, it's going to come with default code. That's what, if you're using only virtual there, that's what it means. But in this instance, we are inheriting from there, so we're just implementing it. I was just making that example. So if you have an overrideable function, then let's change it to overrideable. You see that my code will start working. Because overrideable means that I'm going to provide some basic code that of which, so basically overriding this function becomes optional when you just put the virtual keyword. It's optional. You can or you cannot. It's up to you because it's going to have default code at the end of the day. So as you can see, I don't know why this is doing that now. Okay, let's just do this. Let me comment that out. Okay, let me just do this. Let me see now if it's Okay, I don't know why it's complaining, but oh, maybe because it wants me to have this. I don't know. But yeah, that's the difference. If you have this, you could create the object. Let me just not use the new keyword. Let me just put it like this. You see, I can create the object because this is just an overridable function. Now it's optional to override it. Maybe I could just have one value. Let's say it returns an integer, right? I could just return maybe 0. Just in G, just to return a value. So I could just do that. And then all the other classes, it's optional to override it. They can either override it or they can choose not to override it. If they don't override it, they take the base class's code. That's how it works. But then if it's pure virtual, it means you have no option, you have no choice. You have to do this. You have to implement it. There's no choosing of okay, I'm not gonna implement it, I'm gonna do it. It won't allow you. There's no choices. You have no option. You have to implement it. So that's the difference. So the fact that if they say this is if I'm able to create an instance of B, it means that B is complete. Basically, it means that it's not an abstract class. So since it's not an abstract class, therefore the answer has to be false. Because here they said, is B also an abstract base class? No, it's not, because I'm able to create a new instance of B. So the answer is going to be false. It is actually a complete class. It's not abstract. So it's going to be a complete class. So it's going to be false. Class is complete because you can create an instance of the class. You can create the object. You can remember you can create an object of something that's incomplete. Keep that in mind. It has to be complete before you can create an object of that class. Okay, I spent a lot of time explaining that, so let's just try to move a bit quicker. Assume that class A has a data member M, right? So assume it is the data member M, and class B is an A, while C is unrelated to both A and B. Is N, what are they talking about here? Why would they say is N? They just say is A. I think they made a mistake. It's supposed to be is A. I think that's why they even highlighted it like this. So class B is A. So basically, let's see. Let's try to write it down inside in our code. So I'm just gonna remove this, and then let's create the classes, right? So we're not gonna have this special function anymore because I was demonstrating that previous question. So it has a data member M. Just call it, you can use any data type. I'm just gonna say int M and initialize it to 0, right? That's the data member that it has. Okay. What about this? Okay, now it's stopped moaning. So let's continue. For class A, so class B is A. So basically I inherit from class A. So class B inherits from class A. Public A. So when they say is A, remember that I can have a shape here. Then this would inherit. Okay, let me not say shape. Let me say fruit. Then banana. Then fruit. So a banana is a fruit. That's what they mean by saying B is A. That's what they're trying to say. Don't be confused by the terminology. So I'm just going to change it back to A and B. Things exactly how they want it to be. And then we're going to have class C now. So while class C is unrelated to both A and B. So class C is basically a class on its own. It's not inheriting from anywhere. It's not inheriting from class A or class B. It's just unrelated to both of them. It's on its own. It's just a separate class. So let's see what they're asking now. Given that M is visible in A, but not in C. What are they saying? Is a while class C is unrelated to both A and B. Okay, it's unrelated, right? So given that M is visible in A, yeah, it's visible, but not in C. What keyword was used when declaring M? Oh, okay. So I don't know what they're talking about because they didn't use any inheritance here. It had made sense if they had inherited all of them, or they just used A and B to explain it. It would have made much more sense. But here they just said C is not related to both A and B. It's not related. So how come you're asking me something about class C? But I know what the answer they're looking for here. So given that A is visible, M is visible in A, I feel like this question they didn't something was off about this question. If I'm not if something was not off, then I don't know. Because the way they're asking it is a bit weird. But let's see. Given that M is visible in A, let's say M is visible in A, but it's not visible in C. But how can you say it's not visible in C when C is not inheriting any of these classes? It's not inheriting from any of those classes. So what's the point of C here? I don't get the point because either way, C has no access, no matter how hard it tries. It's never going to have access to, it's never going to have the access to the variable in class A because it's not inheriting. There's no composition. There's nothing. There's literally nothing that C is that relates C to A and B. What keyword was used when declaring M? So I think the keyword that you'd have to use here is private. The thing is that the way they ask this question is very vague. Like this is very vague, but it has to be private because they said it's visible in A. If it's visible in A, but it's not visible in C, but I don't know why. I don't know. I really let me just double check something. I don't understand why. How can they phrase such? How can they phrase it in such a way? I don't get it. Let me see. They're saying it's protected. I don't understand why they would say it's protected. Why would it be protected? They didn't phrase this question properly. It's unreal. I mean, let's read it. Let's read it again. But I don't see. I think what they were trying to say is that the variable is visible in B, right? Let's say the class B, but it's not visible in class C. Then would say it's protected because only classes that inherit from each other are the classes that should only have access to it. So it should be a protected thing. It's a family secret. They see this question. They should have tried better. If you face anything like this and during the exam, right, you have the right to raise your hand and ask because this question is very confusing. It's very vague. It's not like you don't understand English. It's vague because they're saying class B is an A, right? So basically, class B inherits from A. But then class C, they're saying it's unrelated to both. There's no composition, there's no aggregation, there's no inheritance, there's nothing. C is standing alone. Okay, I closed this thing by mistake. You see, C is there, it's standing alone. It's alone. So how can you ask me about C's access to this variable? How can C access this variable? It's impossible. It has no access to that variable because it's unrelated. So the answer there should have been private. based on how they asked the question, should have been private. If you, I'm going to say this again, if you ever face any issues here, you don't understand the question, raise your hand and ask, and when you're asking the question, right, explain it to them how you're understanding the question. And then they'll read the question and be like, oh yeah, it wasn't phrased properly. So we actually wanted to phrase it like this. Yeah, but it makes sense. This was a 2021 paper during COVID. Yeah, it makes sense. But yeah, there's a saying the answer is protected. But I would have, based on how it's written, I would have chosen B because they're saying it's visible in A, but not in C. So it's going to be private because it's only visible in A. It's visible to itself. If it's visible to itself, it's private. They didn't say the variable in M is visible in B. It didn't say that. If they said it's visible in B, but it's not visible in C, and all of them, and let's say, okay, not even if they hadn't said maybe the inheriting or whatever, C inherits, if they read, if they left it exactly as it is, and then here they said in B, if it's visible in B but not in C, then you'd know that you have to use protected. But yeah, they want you to say protected, but don't worry, there won't be. This is a 2021 paper. From now on, it's going to be straightforward. Since you guys are writing on campus, it's no longer online. It's going to be straightforward. But yeah, this was a question that you're bound to lose marks on because it's not clear. They're saying class B is an A, right? So basically, it's inheriting is A relationship. Class B inherits from A, while class C is unrelated to both A and B. And then they're saying if it's visible in A. Obviously, if it's visible in A, then it's going to be private and not visible to this one. Then it's only visible to A, it's private. They made a mistake there. Assume that the class question 1 supports operator chaining for the equality operator. It supports chaining for the equality operator. Yeah, it supports chaining. Yeah, okay, I see. Supports chaining. So you can chain it. What would an appropriate return type for the operator? For the what would an appropriate return type be for such an operator? The return type would be C. It's Boolean. There's no thinking about it. Remember this value. It evaluates if it returns a truth value, either true or false, depending on whether the left hand side was indeed equal to the value that's in the variable on the right hand side. It returns a Boolean. So true or false. It's always going to be Boolean. So bool C, right? If I'm not mistaken. Yeah, C, it's Boolean. So write your answers. Okay, this one about abstract data type. So there's going to be the same answer here. Consider the lines of code which makes use of a hypothetical classifier class, which takes in a PPM encoded image string, right? And returns a Boolean value indicating if the image is of a cat. You see, they're just saying classify, right? You use so that means it as you're using an instance of classifier, and then you're calling the classifier function, and you're passing an str image. Would you based on this, would you consider the class to be an abstract data type? Justify your answer with reference to the requirements of an abstract data type. Yes, it is an abstract data type. Why am I saying so? Because you don't know how the classify function was implemented. It doesn't show any implementation details. There's no way where it shows how this is implemented. All you know is just, okay, I'm going to call a classify function that takes in a string. That's it. You don't know how it's implemented. You don't know how it finds if the image is a cat. So you could also explain based on what you're given. based on what it's supposed to do. I would say yes. Say yes, and you can just say the logical properties are kept separate from the implementation details. As we can see, the function does not show how it implements the algorithm to specify if it's a cat, right? To the algorithm to specify if the image is a cat. So basically, you don't know how it finds how it implements the function, or how it implements that class or function or whatever that thing is. As long as you don't know how it implements, then it's an abstract data type. You don't know anything. The implementation details are kept separate from the logical properties are kept separate from the implementation details. So basically, you have a header file and a CPP file. That's what's going on here. If you had only a CPP file, you'd see both the declaration and implementation at the same time. So therefore, we can't say that's an abstract data type, because I could see the code itself and see, oh, okay, they used the for loop, they went through the images, rows and columns, then they checked if the value has this and this and this. I can see the algorithm. I can see the code. Here, can you see the code? You can't. You don't know how the classify function was created. So it is an abstract data type. And then 1.8, consider that a student is a person, right? So a student is a person. So student inherits from person. And that both student and person define a void member called work. So both of them have a function called work. Your friend expects that the following code will produce the output for students' work function. For the work function, but instead it produces output for the person. What is wrong and how can it be fixed? So basically, your friend expects that the following code, it should output the work for the student, not the work for a person, but instead it's outputting the work for a person. So let's see. I think we're gonna have to talk about some few things here. So what is wrong with this code and how can it be fixed? So the thing that's wrong here, let's see. You create a pointer, right? You create a student object, and then you allocate a student on the heap. And then you create a person object with the letter P. And then you allocate that person on the heap. And then this line is the one that messes up everything. Because what this line does is you're saying take the address of the person and store it to be the address of the student. So now student points to the address of person, and then now it outputs the work for the person. Remember pointers when you're doing pointers. When you use that name, that variable without the asterisk or without the pointer, P is stores the address, S stores the address. And then when you use both of them together, what you're what you're saying is that point to that address and get the value. In this case, we have classes, we have objects. So it's going to point to that address and get the literal object. As you can see, we created the object. So what's wrong here, you need to specify what is wrong, right? What is wrong? You need to say this is wrong. So we need to say S is equals to P is wrong. I don't know why they did that though. They're creating a person and a student, right? And then now they're pointing to the address of a person. Why would they do that? Your friend expects that the following code, how can it be fixed? You can just remove the line of code because I don't see its purpose. I literally don't see its purpose. I don't see it there because person, remember that person is going to be the base class, and the base class most of the time it doesn't have all of the implementation. It's generic, right? It's generic most of the time, so it's best to just use the child classes. So this is wrong because this object s address is updated to the address of person object T. So yeah, you made the object, the student object S. So I'd say the student object that, and then person object, but even put it in single quotes like this. Here we go. Then wrong because the student object S is address is updated to the address of person object P. So basically the student points to person. And how can it be fixed? I don't know why they would do that. Me, I'll just say remove that line because there's literally no purpose for that line. Move the, and then you can just say how can it be fixed. Let's say remove the line of code because I don't see what purpose it serves. If they had said, I don't know, maybe the memo is going to be different, but this is how I would have approached it because what's the point of doing this? Why? Why are you doing that? I mean, there's no point in doing that at all. Okay, let's see. Let's go to the next question, 1.9. Your friend is adding and removing values from a linked list, but is frustrated. Yeah, linked lists. If you don't understand pointers, you're in trouble. Is trying to add and remove values, right? Remember, adding and removing is just changing the pointers, the arrows, where are they pointing? You need to update that. He's frustrated that the order of items keeps getting reversed. What data structure is behaving as, well, what is this? What data structure is this behaving as? And how can your friend fix this? Okay, it's a bit of a tricky question. Yeah, because yeah, this is 2021. I wasn't playing. You need to know what you're doing. Yeah. So your friend is adding and removing values from a linked list, right? So I adding and removing, and then the order is being reversed. Oh, I think I might be onto something. Let me see. So let me see. We have let me see. Let me just create the damn document there. Let me insert the image because I see if I share this code, this file, the problem with that. The problem with that is that Gen 1 is going to be 1.1, right? Yeah, I think this is 1.1. CFC 1B 1. I'm just gonna call it this. I'm just gonna do this, copy all of this, cut, then paste it here. Yeah, let me open Notepad. For some weird reason, whenever you're copying things on things, then do this. Cancel, cut, should save properly now. There we go. Let's see, protected. There we go. And then 1.9, adding and removing, right? But then the order keeps getting reversed. So let's see. So I have this linked list, right? 1, 2, 3, 4, right? So this is the order of the linked list. And then when I want to add something, I end up adding it to, because they're saying the order is being reversed. So that means it's instead of it retrieving from the front or adding. So in terms of working, instead of it working with the front, right? What's happening is that it's now working with this rear end. So if you want to add a value, it's adding it it's adding it. Wait, let me see. Adding and removing. Let's think. Adding and removing. Oh, the order is being reversed. Okay. So let's see. So if I add value 1, right? And once if I want to add the value 2, getting it like this. And then if I want to add the value 3, getting it like this, right? Adding and removing. But then I don't know about the removing part because it didn't specify how it's being removed, what order, but the adding part I can see. So it's reversing the order. Oh, okay, I see. So let's say you want to remove, right? So it's going to remove this like this, then you're left with this. Okay, so it's like you're working, it's doing it in reverse. I see now. So it's doing it in reverse. So if you want to add 3, it adds it in front of 2. If you want to add 4, it adds it in front of 3, like this. So as you can see, now you are, what do we call? This is going to be a stack because now what you're doing is you're pushing from the you're pushing onto the top of the list. And then you're also, if you are removing, you're removing from the top. Why am I saying so? Let me show you in in using a drawing. It's exactly okay. No, I opened the wrong thing. Mm, Now I lost my case. Where is it? Okay, still loading. Exit. I don't want to make PowerPoints. Open the wrong thingy. Where's that? The other one. Where did it go? Okay, there it is. So you see what's happening, right? Let me show you. So what's happening is that you can imagine that this is what's happening. I have this, right? This is like my okay, this is not the one that I want. Why is it so big? Okay, because I zoomed in. Okay, I see. Let's do it like this. And then I'm going to add text. Let's insert text. Why does the text have to be so big? What's going on with this thing? And this thing annoys me, man. Sometimes the text is big, sometimes it's small. I want to insert the text inside here. Uh, Let me try and insert again. I think it's all mode. So let me try to decrease. I don't know if it's even working, but yeah, let me try to decrease the size. Decrease size. Decrease once more. I hope it does work. Still shows this thing the way that I don't want it to show. Can't you just, you're supposed to have an option to just add the text. Okay, let me just insert it in the okay, this thing is you know what? I'm tired of this thing here. Let me use Pro.io. This thing is getting on my nerves now. Pro.io. Let me see how far am I? It's already 1 hour. Yeah, nah. These videos are gonna be very long. Some people are not gonna like this, they're gonna be annoyed. But it helps though because I'm explaining everything as I should. So you're gonna imagine this is like 1, right? This is 1, right? So instead of it, remember that with the linked list, you insert after 1, right? So basically I should be inserting underneath 1, right? But then now what's happening is that this is happening. Copy, paste. This is happening. It's inserting at the top. So basically it's reversing the order. So it's going to have a 2 there. So you see, now we start having what? A stack. So what's happening is that we're having what? A stack now. Because it keeps on inserting at the top instead of it inserting in increasing order, like in a linear form. Now it's adding on the top, or basically in the front. It's going to act like as the top of the stack. So it's something like this. And then there we go. So it's going to be like this, a stack. You see, you can imagine each each rectangle as like a plate or whatever that thing is. If you remember your slides, there's a stack of plates, right? So if you notice a stack of plates, you see how they are. You keep adding to the top. So you see now it's reversing the order. So it's going to say 1, 2, 3, 4, 5, 6, 7, 8, and so on. It's reversing the order. Remember, this is a linked list. It's reversing the order because whatever value I have in the front is going to be the first value that I get from the linked list. So in a way, it's going to be, this is how it looks, right? This is how I'm going to represent it in terms of how it looks. And then in terms of linked list wise, it's going to look like this. You're going to have this. Okay, let's start it from this side and copy paste. Then I'm going to say this is the address, that pink one, and then this is the value. So here you're going to have the value 1, right? Because that's the first node. That's the value of the first node. And then now what happens is that whenever you insert a new one, it inserts it to the front, basically mimicking a queue, a stack. And then now you're going to have an arrow from here. Okay, now I want this one. Yeah, so now you're going to have this. Remember, this pink part stores the address of the next node. So this one's going to be of value 2, right? As you can see, it's now in reverse order. It's not how you'd expect it to be. You'd expect it to start from 1 and going upwards, but now it starts from 4 going that side. So yeah, it becomes a problem. Oh, okay, the arrow. Yeah, I made a mistake. The arrow needs, it shouldn't be like this. This should be like this. And then this should be like this. And then I move it to here. There we go. Yeah, this is now how we exactly, this is how it actually looks. So now I need to copy this, and then there we go. This is going to be the integer value 3. And then the address is going to point to this one. So now you can see, right? It's becoming, it's going in reverse order. You see, it's in reverse 3, 2, 1 instead of saying 1, 2, 3. So in a way, it's mimicking this stack. So in a way, it's like I'm adding on top of the stack. So it's mimicking a stack. Because imagine I had the node with value 1 first, right? And then I added to the top or in front of that node. And then I also add it in front of that node again, which is basically this. You keep adding. So it's like you keep adding to the top of the stack. So it's mimicking a stack. And then now we need to answer the question. Let's see what's saying here. To answer my question, let's answer the question. What data structure is this behaving as? In simple terms, it's simple. What is it behaving as? That's all you need to write. It is behaving as a stack, right? Simple. It's behaving as a stack. That's one mark. And now the other question is, how do you fix it? So how do you fix it? Because what's happening is that it's now adding to the front, right? So the way you fix it is you should stop adding and removing from the front. You should add and remove from the back. Because if you add and remove from the back, this is how it's going to look. You're going to have value 1 first, right? And then to add 2, you add to the end, which is 2. To add 3, you add to the end, which is 3. To add to the end, it's going to be like this. You add a 4. Then you have a linked list. To remove, you remove from the back, like this. So basically add to the back and remove from the back. That's the answer. So add and move nodes from the rear end, basically from back. That's how you should be adding and removing. Then that's it. You're done with this question. Even though it was a bit tricky, but yeah, I feel like I should use draw.io. It's a bit better, even though my screen is a bit small, so you can't really see everything. But yeah, we'll just have to work with what we have. So 1.10, name the object-oriented concept. Name the object-oriented concept is being described. You see, they're making a lot of errors. That is being described. That's why I couldn't read it properly. So 1.10, I'm gonna go here, 1.10, and start with I. What object-oriented concept is being written? A project's day team has students, right? So a project's day team has students. Can the students exist without the project's day team? Yes, they can. You can be a student without a project's day team. So you don't need remember a student, right, is like a person, right? So in a way, what you're asking, the question that you should be asking is the student or the person in order for the person to exist, do they need a team? No, they don't. So it's going to be aggregation. So always ask yourself the question, look at what's on the right hand side. In this case, students. Ask yourself, does this depend on the existence of this on the left hand side in order to exist? Do students depend on the project's day team in order to exist? No, they don't. You only depend on your parents' existence in order to exist as a student. Or depending on, yeah, you can phrase it in whatever way you want to phrase. Or depending on your acceptance to be a student, you need to be accepted. But either way, I feel like, yeah, it's aggregation. You don't need a team in order for you to exist as a student. You don't. You need marks, you need an acceptance letter, you need all of those other things. Those are things that make sense. Not a team. You don't need a team to be a student. Yeah, there's no way that they're gonna say, oh, in order before you enter UJ, you need a team to become a student. That's not a requirement. So that's aggregation. One can exist without the other. So this is going to be aggregation. Then two, let's see what we have. A student as organs. This is composition. The organs cannot exist without the student's existence because the organs are part of the student and the student manages their organs depending on your diet, depending on your food. The organs need the nutrients and all that. So you need to eat. You as a student are managing its existence. And without your existence, the organs themselves don't exist. It's like a heart. Can a heart exist without your existence? Can you take out a heart out of you and it will still beat? No, it won't. It will stop beating. It will stop existing. So there's a life cycle dependency. This is composition. So composition. Then three. Let's check three. Where's okay? There you go. A project is an academic activity. So this is this is simple. This is just basically what inheritance is A. So a project is A, so it inherits from this class, academic activity. So this is inheritance. So this is just inheritance where there is a relationship. And then aggregation has a relationship. Here there is no life cycle dependency. Therefore, one can exist without the other, in simple terms. And then I'm also gonna copy this and put it here. There is life cycle dependency. Therefore, one cannot exist without the other. That's what composition means. When you're done with question one, that's all you had to write for question one. So I'm just gonna keep the video short. That's it. I'm gonna see you in the next session.